Hi friends, welcome to follow up. Let's have a look at problem 2785, sort vowels in a string. In this video, basically we aim to practice using index or some function like array pop method or enumerate function. So here we are given a string, right? So we are given a string and it contains vowels and consonants. So we want to sort the string. So we want to keep the consonants unchanged. Well, for the vowels, we want the vowels to be in a let's say non-decreasing order. So basically that's the problem statement. So notice that in this problem, S consists only of letters of the English alphabet in uppercase and lowercase. It's not only lowercase but also uppercases. This is the point we need to pay attention to. So the first constraint is the length, right? So for example, you see, look at the first example. So here L, T, C, and D does not change. So then we have E, capital E, little e, and O and E. So then we have this order, right? E, O, E, E. So the capital letters comes before the lowercase letters. So this is the first example. For the second example, so it does not contain vowels, so it remains unchanged. So basically that's the problem statement. So here actually the strategy maybe just to sort the vowels. So here the caution is that we need to pay attention to the indices. So here I'm going to provide two solutions formats. The first one is aiming to understand the detail, and the second one we sort of shorten the first solution. So here first let's get the length of this S, and also for convenience I'm going to use a dictionary or set. So here set. So the vowels, right? I, U. So here we need also include this one, the uppercases. This is just for a check purpose. And then we can get the vowel indices, right? So let's see, let's call it vowel indices. So here basically let's make a list. Actually this can be easily retrieved, but let's see, let's do a loop, for loop for I in this range. So basically if Si in aux, so basically it means that this index corresponding to a vowel index. So we're going to do this vowel indices. So append, right? Append this I. Then let's also get the vowels. So the vowels, so it's easy to get, right? So basically we can use a list comprehension, right? For I in range, let's see, for I in not in range, in vowel indices, right? And then in order to make the vowels in a non-decreasing order, we can sort, right? So vowels we can sort in place, right? And then we can basically get the correspondence of the vowel indices with the vowel. So if you like, so you can use a dictionary, right? So I, this is the index, is the corresponding vowel. So for I, V in zip, let's use this zip function. So this is the index, so vowel indices and vowels. So basically you do not need to specify this, but here for this version we just want to understand the detail. And then let's get the result. So for this result I'm going to, for I in range n, right? So basically if Si and not in the auxiliary list, dictionary, not dictionary, is set, it means that this index corresponding to a resonant. So we just need to append Si itself. So otherwise, so we're going to append the corresponding vowels. So this will be D of I, right? So here this is a list indexing. So here is dictionary indexing. So we add this one, Then we're going to get something like this. So you can print out if you like, right? Print out this result. So, and then the return basically is nothing but just use a join function, right? So we get this one. So now let's look at this first example. So we have, so this is a resonance does not change. So this is the E. So we change the smallest one. And this capital E changes to be this O, right? So we have resonant, and then this changes to be E, and the last one is remains the E. So then we join them together, so we get the result. So let's comment out this print and then do a test. Yeah, it passes all the cases, but you know, for this format of writing the code, it's actually sort of long. So let me copy this function signature, and then let's shorten the solution. So here, basically, what I want to do is that, so I can copy this part. Yeah, even we can shorten these two lines, but we have this N and the vowels. So we can get the vowels first. So vowels will be character for character in S if character not in Aux, right? So then what we are going to do, so here I'm going to sort in a reverse order. So sort reverse equals true. Then you will digest why we sort in the reverse order. So basically it's in the return format. What I'm going to do, I'm going to use join method for sure. So here I'm going to use list comprehension. So basically vowels
I'm listening.
Pop if si in Aux. In other words, we are seeing vowels, so we're going to pick from this one. And else, so basically just use si, right, for I in range n, right? So that's why we use we sort here in a reverse order, right? So this second solution format actually is the same in essence with the first one, but it's significantly shorter. So now let's do a test. It's not right. So let's see what's the problem. So we have n, we have this, we have reverse, and then we have pop if si in x, else si for I in range n. Let me see what's the problem. So we have this vowels. So here I guess there's some problem. So here is not si. If si in Aux, else if si in Aux, else si. Let's test again. So let's see what's the problem. Vowels pop if si in Aux. If si is a vowel, right? So we're going to do pop. Else just use si for I in range n. It should be right. So our output does not contain vowels. So let's see. If si in Aux here actually this is the right one. So here we write a more not, right? So now let's test. Yeah, it passes all the cases. So now let's do a submit. Yeah, it passes all the cases. So with that said, basically that's about it for this video. Thank you.